Let's get started on Chapter 6, Network Reference Models and Standards. This is a nice, short chapter. In this chapter, we will discuss the OSI Model, Standards, and IEEE, the Institute of Electronic and Electrical Engineers. Let's start out with the OSI Model on page 264. In this section, we will ask the following questions. What is a model? Why do we have a model? What is the OSI model? What are the layers in the OSI model? And what function is performed at each layer of the OSI model? So let's start out with what is a model. A model divides an industry into categories for purposes of specialization of labor and modularity. For example, the building industry is divided into categories such as foundation, framing, plumbing, electric, roofing, and other. And the reason that we divide the industry into those categories is for purposes of specialization of labor and modularity. Specialization of labor means the roofer gets really good at roofing and makes really good roofs, but doesn't know much about electricity. And the electrician gets really good at electricity, but really doesn't know much about roofing. He leaves that to the roofer. And then modularity means you can change any one variable without changing the others. If we wanted to change the roof from cedar to slate roof, what would we have to do differently with the electricity? Nothing, because they're independent variables. We can change one variable without having to change the others. If I wanted to change the voltage from 110 volts to 220 volts, what would the brick layers have to do differently? Nothing, because they're independent variables. A model divides an industry into categories for purposes of specialization of labor and modularity. Now, let's look at the OSI model. The OSI model divides the networking field into 7 different categories, what they call layers. Some of you in your career may become cabling installation specialists, in which case you will be working at the physical layer, and you'll get really good at cables and know all about cables, but you might not know much about web page programming. Conversely, others of you may become web page programmers, in which case you would be working at the applications layer, and you know all about web page programming, but probably not much about cabling, but you don't need to. You leave that to the cabling guys. So there are 7 layers in the OSI model. So let's look at the function of each layer and an example of each. 7 layers for the OSI model. We'll start out with layer 1. Layer 1, the physical layer, is concerned with cabling, such as twisted pair, coax, and fiber optic. Layer 2, the data link layer, is used to eliminate or at least reduce collisions. And we already saw that CSMACD, Carrier Sense Multiple Access Collision Detect, is a protocol which is burned into the firmware on a network interface card for the purposes of reducing collisions. And then the purpose of the network layer is to send packets. And of course, IP is the perfect example. The purpose of the transport layer is acknowledgments and flow control. And of course, we've discussed the TCP protocol before. The session layer is concerned with establishing sessions between 2 computers. Now, my computer in my office is hooked up by way of cable to the server, which is upstairs. But that doesn't mean that I am logged on to that server. It just means I have a physical connection. The session layer is concerned with sessions or logons between computers. The presentation layer is concerned with translation, encryption, and compression. And most of you are familiar with the applications layer. The Hypertext Transfer Protocol is the protocol of the World Wide Web, and the FTP protocol is used to copy files across the internet. 7 layers to the OSI model. Now here's the funny way to remember the 7 layers of the OSI model. It's a mnemonic, and the mnemonic is all people seem to need data processing. And that helps us remember the 7 layers of the OSI model and their order. So the OSI model divides networking into 7 layers for purposes of specialization of labor and for purposes of modularity. Modularity means you can change any one variable, but you don't have to change the others. In other words, if I wanted to change the physical cabling, what would we have to do differently on the web pages? Nothing. They're independent. Conversely, if I wanted to change the contents of the web pages, what would I have to do to the physical cabling? In most cases, nothing. Modularity means you can change one variable without having to change others. And then the OSI model is also used in communication and troubleshooting. I said to my fellow technician the other day, I am having a problem with a user and I can't get him logged on to the server. And he said to me, did you check the cables? And I said, I can already ping the server from the workstation, therefore I know it's not a layer 1 problem or layer 2, 3, or 4, probably a layer 5 problem. OSI model can be used in communication and troubleshooting. Now let's discuss standards. What is a standard and why do we have standards? Well, I think everybody knows what a standard is, but here's one example. Have you noticed that the bottle cap for Pepsi bottles also fit Coke bottles? Isn't that interesting? They're totally different companies and they don't even like each other. So how is it the bottle cap for one fits the other? Well, that's because they used standard 2-liter bottle caps. It's standard meaning it's what everybody uses on 2-liter bottles. Here's another example of a standard. If you were to manufacture electric fans, at what voltage would you design those fans to run? Would you design those fans to run at 70 volts? No, probably not. Why not? Well, because the standard is 110 volts. In other words, that's what most buildings use. So you could make a fan that operated at 70 volts, but it wouldn't fit the standard, and the fan wouldn't work. So a standard is a consistent way of making or doing something, and the reason we have standards is so stuff will work together. The IEEE, Institute of Electronic and Electrical Engineers, is an organization that's dedicated to advancing technological innovation and standards. IEEE sets the standards. Let's look at the IEEE 802 specifications. These are specifications specific to the networking field. We have IEEE 802.1 all the way to IEEE 802.23. Now, you're not expected to memorize all of these, but you probably already recognize that IEEE 802.3 is the standard for Ethernet. And IEEE 802.11 is the standard for wireless networking. It specifies voltage and frequency. So, if you were to manufacture network interface cards, and if I were to manufacture switches, we would both follow the IEEE specifications. How come? So your network interface card would work with my switch. So, Chapter 6, Summary. In this chapter, we discussed the 7 layers of the OSI model, standards, and IEEE. And this concludes Chapter 6. Thank you very much, and have a nice day.